I'm trying to create a climbing system based on one of my favorite games of all time, Shadow of the Colossus, which is a game where you climb all over these massive monsters in order to slay them. And I've been trying to solve this problem without using too much complex maths. So we're reading the mesh data, using plane casts, and trying to intuit how to solve this problem. And we've already figured out how to climb all over an animated mesh. And please check out the first video if you're interested at all in how I got to this point. So I've been tackling the next problem that we face with creating this system, which is that currently there's no limit to where we can climb. In Shadow of the Colossus, you can only climb on these furry patches, and that's where half of the challenge of the game lies, navigating your way up these moving levels and trying to figure out how you're going to get to the top. So what should happen if we're climbing and we reach an edge? Should we stop? Should we pop off? Well, the thing that makes sense intuitively to do is to give up and go and cry in your room because this is hard. The next most intuitive thing to do is to continue moving in the approximate direction that we're trying to move with the joystick. In other words, basically sliding along the edge, because it would feel weird if your momentum just kind of stopped whenever you hit an edge. You can see this in action in most video games where you have a character moving around. You walk into a wall and you kind of slide along it based on the angle that you're coming at the wall from and your speed. And so I approached this just like in the last episode with the simplest possible version. The first step is to get sliding working on one edge of one triangle. No corners, no moving between polygons. And not only that, we're going to go 2D rather than 3D because it's easier to think about things in 2 dimensions. And this makes sense to me because the Earth is actually flat, and on the other side they keep all the best water slides which only the billionaires can use. So currently, to move along the mesh, we're drawing a line across it, and the length of the line, once you add up all the sections, is how much distance we want to move this frame, otherwise known as our velocity. But if we reach an edge, because the mesh has just ended, we can instead just extend a straight line out into space. This is our attempted move position, in other words, where we would end up if we just flew out into space this frame. And what I'm doing next is finding the point on the edge that's closest to that position, using this function that I found online. Yes, quite. I know exactly how that works. And then we can just move to that point. And if we do that, each frame will slide, basically. And you can see that if we come at the wall from a shallower angle, we slide less. And here that is working in the editor. So next we got to figure out what happens when we reach a corner. So if we slide along the wall and we're going that distance each frame, you can imagine that if we were to just continue sliding along an imaginary wall, we'd end up about here on that line because that's the closest point on the edge to where we'd move if there were no corners. And so we can assume that we'd shoot past this corner somewhat. But how do we get that position? We need a slightly different function that gets the closest point on a finite line. And so instead of checking the first edge, we want to check the next edge. And we can get a point on the next edge like this, but it occurred to me that there's an area in this corner where your attempted move position can vary, but the closest point on either of these edges remains the same. Incidentally, you can draw a right angle to these edges at the corner to find that area. Anywhere in this area, the closest point is going to be in that corner. It doesn't really make sense that you can move at different speeds but end up in the same place. We want to make sure we're getting realistic measurements because otherwise the movement's going to appear jerky. So then I thought, okay, what if we take this measurement along the wall that we're traveling to the corner, and then we subtract that from the total distance that we're trying to move this frame. Then we get a new attempted move position, find the nearest point, move to that. But that doesn't quite make sense either, because if we're moving into the wall at an angle, then the distance we just tried to go to perfectly get to that corner isn't this, it's this. The difference between them seems negligible, but it's much more obvious if you're traveling into the wall at a steeper angle. Again, we can draw a line perpendicular to the wall, and where these two lines intersect is that distance that gets us to slide perfectly to that corner. And we can really easily calculate this intersection using a plane cast that's perpendicular to that corner. So to recap, we subtract the distance that takes us perfectly to that corner, and then slide the remaining distance along that wall. So the nearest point to the speed and direction we're going, we then move to. And here that is working. And if we're moving perfectly into the corner, then we're actually attempting to move into this area that I showed earlier, and the closest point on either of these edges would be in the corner. So we just stop in the corner, which makes sense. So there were some errors happening when I reached a corner sometimes. If you didn't watch the last video, basically the way we're finding the direction we want to move along the triangle is by intersecting a plane with each edge in order to find the point in front. But it turns out that Unity's plane intersection sometimes fails to hit anything if it's perfectly at the end of an edge. So this plane cast will pass right through these edges and also won't work if you're in the corner and facing this sort of direction. And so to fix this, I basically made each of the edges infinite when I was doing this calculation, and therefore there's no way that it can not hit something. Now when we reach a corner though, the player's orientation freaks out. We're currently getting the orientation of the player by grabbing the point in front and behind of them on the triangle each frame, because these points adjust relative to the mesh's deformation, and so we can rotate the player accordingly. But when you're in a corner, there is no front and behind position. They're the same. So it just can't work out the orientation from this. The solution was just to perform the plane cast for these measurements always from the center of the triangle that you're standing on, instead of where you're standing. Then I noticed that when we're reaching a corner, we're popping to another corner entirely. And that's because now we're doing these checks with the infinite edges, we can accidentally get a point on the far edge. But in this specific situation, we know that we're in a corner and we don't actually need to check this far edge at all for collisions. Okay, let's just have a break for a second from edges and corners, because I got a few questions about why I didn't approach this using colliders or even moving around the UV map. Well, I actually came up with those exact same solutions and excitedly rushed to my computer to test them out, because this isn't my first attempt at making a Shadow of the Colossus climbing controller. So, colliders. First we find that the collider doesn't actually update with the animation, so we get that working. But of course we don't just conveniently stick to the model, it slides underneath us. Because this isn't a rigid body moving around, it's just a bunch of vertices. We can try and match our movement to the skeleton of the animation, based on which part of the body we're standing on. So if we're standing on the foot, then we match the movement to the movement of the bone of the foot. And we can use an asset store asset called Rascal Skinned Mesh Collider, which handily splits the mesh up into different parts, so that we can raycast the mesh that we're currently standing on and parent the player to that. And this sort of works, but we're kind of sinking through the model, stopping at edges of where meshes join, moving around on the mesh when we're standing still because the bone's not deforming but the mesh is, and we're just attached to the bone. And then we got other problems like popping off the mesh at weird corners and the collisions always being a frame late because we're updating the collider after all the physics has been handled. And I'm sure we could improve a lot of these problems, but basically it's just not a reliable way to approach this problem. And then for the UV approach, you can see I'm grabbing a place on the UV map here and displaying its location in red. But that's about as far as you can go before you run into all sorts of problems. For example, what happens when you reach the edge of a portion of this model on the UV map? You got to suddenly find out which other part of the UV map you're trying to connect to. And you've got to consider the fact that it's impossible to lay out a 3D model in 2D with everything being proportionate. Just like how the world map's spread out, with Greenland being actually smaller than India in reality. So distances on a UV map aren't going to be consistent with distances in the real world. And every time you cross an edge on the map, you'll be changing direction, and because the mesh is animating, those directions and those rotations won't be consistent frame to frame. Then we've got to translate UV coordinates to world coordinates, and not just that, rotations as well. And that's going to involve some funky maths. And you can try to pick places on the model on the UV map with raycasts, but at that point, what's the point in even using UV maps at all? Because you're just raycasting. So let's go back to the other method, which is working pretty well. Now, if we want to handle a corner made of more than one triangle, we're first going to have to make a list of every single point on the mesh and every edge attached to every point. And then we're going to have to store some information about which of these are outside edges. So before, we already stored some information about which two triangles are attached to each of the edges. If an edge is only attached to one triangle, then we know it's an outside edge. So here you can see I'm displaying all the outside edges because I've separated the green part from the rest of the mesh. Currently, we can't cross a corner like this because there's several edges coming off of one point. The script only works on this triangle that we're standing on, and we don't have a way of just getting the next edge. So we got to figure that out, right? We can look at every edge attached to the corner, and we know the next edge isn't the one we're standing on, so we can get rid of that. And you might think we can just assume that the only other outside edge is the one that we want to move to, but there are situations where more than two outside edges can be attached to one corner. So what I'm going to do is this. I get the current triangle that I'm standing on, and I get the only other edge on that corner that's attached to that triangle. Then I eliminate that triangle that we've just checked, and I get the other triangle attached to that edge. Then I eliminate that edge, get the only other edge on the corner that's attached to that triangle, and so on until I get the next edge. And once we've found that, we can slide over to the next edge. And here that is working on a real mesh. And I was pretty happy with getting to this point because I didn't think there would be many more problems left to solve, but I was wrong. So here's another situation that's not covered currently. When we reach this corner here, our solution is currently putting us on this edge on this triangle. You can see from the red line the direction we're moving in. We want to go to that big triangle just there. So in that last step, each time we check a different triangle attached to the corner, we do a plane cast with its opposite edge. And now sliding works. Woo! And we can handle quite a few situations with this, as long as the surface that we're standing on is smooth. And I'll get to what that means in a second, but I just want to show off something. You can see here, if we're moving forwards in this direction on this mesh, we slide past every point and we eventually get to the end of the mesh and stop here on this corner. But the cool thing is that because of the way that we're checking through the mesh, we can do all this in one frame. We find the next edge, next corner, next edge, next corner, all in one frame. So we can change the movement speed here from 2 to 1000, and we instantly move to that exact same corner that we found before. I just thought that was quite satisfying. Okay, so I just mentioned about soft edges. This is a mesh with hard edges, and you can see that from the lighting on the model. And you can also see that we're not able to go over a hard edge. And this all has to do with normals. Each vertex on a mesh has a normal, which is information about which way the surface of the mesh is pointing. This is how games know how to bounce the light off of a model to make it appear more smooth than it actually is. If a mesh is smooth, all the normals at the corners will point the same way, so they can all share a corner. The normal information, the index of the corner, can all be shared by multiple triangles, but triangles on a hard mesh will not share vertex information. That's a problem because we're currently calculating which triangles are on which edges, based on the triangles sharing vertex information. So that's why we can't walk all over this hard mesh, because it doesn't know which triangles are attached to which edges. The reason we need to consider hard edges is because the angle that the player stands is based on these normals, and it can start to look a bit weird on a big soft edge. So all we need to do to fix this is to decide which triangles are adjacent to which edges by comparing their positions rather than their indices. And this does work, but it created a whole host of new issues, which I did fix, but it kind of hurts my brain thinking about how I'm going to explain them to you. The first problem that hard-edged corners pose is that you sort of flip between triangles when you're moving into a corner. This is because we're moving along an edge, right? And then we find the opposite edge in the corner. And then in the next frame, we find the opposite edge in the corner. And you can see where I'm going with this. This actually happens on meshes with smooth edges too. You just can't see it because the angle that we're standing at is based on the corner normal, of which there is only one. The solution should be to not switch to another triangle if we're heading into a corner, but this doesn't work sometimes. And this one was a real head scratcher. But what I eventually discovered is that because we're abruptly changing the player's angle as we pass over a hard edge, on certain corners we can end up actually pointing back the same way we just came. So the script never actually detects a corner, but you can end up bouncing back and forth in the same way. The solution is to look into the future and check whether this is going to happen. And if it is going to happen, then we just don't switch triangles. And there were tons more edge cases, including the orientation messing up when you're trying to get the far edge. I hope you don't mind, I'm just going to let that guy talk about corners for a while because honestly, even though I managed to solve all this, I can barely keep this information in my head long enough to think of a way to illustrate it to you. So I just wanted to chat with you instead. And thank you Purrple for 100,000 subscribers. This is way overdue and I appreciate every single one of you. I'm saving opening my plaque as a celebration for reaching a big milestone that I have in my head. My uploads haven't been the most consistent, one reason for that being that I literally broke my back, wedge fractures on T3, T4 and T8 vertebrae, and I could barely sit upright for about 8 months, let alone work on YouTube videos, but I'm all better now and hoping to make more videos soon. The other thing to mention is that I took down my Patreon page because I feel bad for charging people for these videos when they haven't heard from me in ages. You know, they might have forgotten that they're even signed up. And I also realized that the end credit animation perk was too much to promise to people when I'm trying to get these videos done. But I appreciate all my patrons so much, you have no idea. So we've reached a pretty good place now. Soon I'll be diving more into the animation and gameplay side of things. Might not be the next video I release, but I hope you'll join me for that, and I hope you're enjoying this in-depth process behind making this. Please check out the first video if you haven't already. Cheers, and I'll see you in the next one.